So here we are in a space with no acoustic treatment. So it was done on purpose, so we can experiment what would be, reverberation. Is it? Yes. And so how it impacts the speech intelligibility. So when we move from this room to the well-treated space, then we can feel the difference. You can hear here the difference. You feel it. It's very much
significant.
Very significant. Much comfortable.
What's the magic?
Yes, the magic is the acoustic design.
Could you briefly introduce yourself?
I'm a physicist engineer. My specialty is acoustic. I founded the Delhom Acoustics 25 years ago. We do acoustic consultancy. We are based in Europe, in France, Toulouse and Paris, and also in China and Vietnam. I'm based personally in Shanghai.
25 years, that's
yes.
Amazing. Have you seen the changes?
Yes, I've seen changes, especially in China, where changes are very fast. People are really learning very quickly, so changes are faster in China than in Europe.
You mean business or technologies?
Awareness. There is an annual survey from the Ministry of the Environmental Protection of China, showing that the noise is the main concern after air pollution among Chinese people for environmental aspects. So it means that people are really aware and they are complaining about this.
What is acoustic?
So acoustics is a branch of physics that study the sound propagation, emission and reception. So we use this science to improve the comfort of buildings, for example, well-being of people. This is part of our job, our role.
What is the history of acoustic science?
The history is quite long history because we have found that Greek and Roman theaters were built with acoustic knowledge. People really studied the acoustic of these theaters. So it's a very long history. It's more than 2,000 years. Recently, with the computers technology, acoustics has evolved a lot. New tools, new models that allow us to really take into account all these acoustic comfort criteria take into account in the project, in the buildings. So for the last 30, 40 years, the changes are quite big in this science.
I think in most of people's eyes, acoustic design is required for some very special spaces, like theaters you mentioned.
Yeah, this is true, of course. You don't do a theater or a concert hall without acoustic science, but in fact, most of our clients are not this type of buildings. We work a lot for offices, for hotels, for residential, for museums, hospitals, schools. Every type of spaces where people interact needs acoustic comfort.
What are acoustic issues in office?
Maybe the most difficult part for offices, I would say, is the open space. Because in these spaces, you have two targets that are conflicting. Because you need to be able to communicate with your colleagues easily, but in the same time, you don't want to disturb others. So it's complex because you need to address these two opposite targets. So the balance is quite difficult to reach. It's maybe one of the main challenges in the offices, the comfort in open spaces.
What are the best solutions?
The best solution is to limit the propagation of the sound and the noise, so with absorbent materials. But in the same time, if you bring too much absorption, you will improve the clarity of your voice. So people at maybe 10 meters or 15 meters can understand you, so they got distracted, which is the main issue in open spaces. So it's a balance between the clarity, sound propagation, the control of the material, and very often the designers, they think that you just add acoustic materials and that's it. But in reality, each material has its own property. Some materials will absorb the high frequencies, some material will absorb the low frequencies. So to get the right balance, you need to mix the different materials, different properties with different quantities. All materials has acoustic properties. And when we designed this space, we took into account the acoustic properties of all materials, including the furniture, the wall, the floor. Even this floor, it has some acoustic properties.
What is your role as an acoustic consultant?
Our role is to help our clients and the designers to integrate the acoustic comfort into the project. Ideally, we need to work from the beginning because we can avoid a lot of cost and a lot of complexity. Because if we start very early in the design process, we can integrate all solutions into the design. Some years ago, we were designing a big conference hall for Airbus headquarters in Europe. We did the modelization of the concept, and we saw that this room with glass wall everywhere had a very strong floating echoes inside the room, so it would be very uncomfortable. So there are two solutions to solve that. One solution is to change the angle of the walls very slightly, so you don't see it, and then you kill the unwanted echoes. Or the other solution is to add absorbent materials. But this would cost money. This would change the design. So because we were early in the concept phase, we discussed with the designers and we just changed the angle of the wall.
Mm-hmm.
And
that's amazing.
And it cost nothing. It didn't change the design, and was very efficient.
What are the major challenges?
There are many challenges. Maybe the fact that we need to convince our clients and the designers that we can adapt the solutions to their design without any change. And maybe show them that if it's properly addressed, we can have very low cost. Like for example, the HVAC noise, if it's properly designed at the beginning, sometimes you just need to choose the right size for the ducts, and then you control the airflow speed, and then you have no noise. If you have to do it after it's built, it will cost much more because you have to change everything.
So WELL is a very famous healthy building standard.
Mm-hmm.
And I noticed a very interesting change from version 1 to version 2.
Yeah.
They actually lowered down the requirement for acoustic performance.
It's mainly for the background noise. And I think this is not the trend. I think it's I guess they will change it in the next version of WELL, because the noise level their request is quite high and not really compatible with the sound masking systems, for example. Most standards are going down. They are increasing their demands in terms of acoustics. So I think the trend is to be stricter and stricter, not like this example you gave for the background noise in WELL. I think this will be changed.
Today we're in Element Plus. It is a WELL Gold project.
Yes.
And I think it is amazing.
Yes, of course. We are very proud because we were working with the robot spaces. They understood what we were doing, so it was very easy. In fact, it was very flawless because they gave us their concept. They gave us what they wanted as a designers, and then we adapted the solutions to integrate them into their designs. It was a good cooperation. We completely follow their design, so it's possible. It's not only ugly materials that you put on the wall, and it can be completely part of the integrated it into the design. If the designer wants to use wood, we can use wood. If he wants to use glass, we can use glass. If he wants to use metal, we can use metal. Everything is possible. We can see how it has been integrated into the design. So, for example, here we have acoustic materials on ceiling, like these baffles or the flocking spray on the ceiling that brings absorption in high frequencies. The baffles maybe more like lower medium frequencies. So it's the mix of this material that brings this comfort. Mm-hmm. We have here another example. This pillar is covered with acoustic materials, so it's PET with a special foam behind that bring acoustic absorption in medium frequencies. So The mix of all the products creates the feeling of comfort, the good speech intelligibility, decrease the sound propagation, the noise propagation in the space. Here, for example, we use the green wall, has absorbent material, so it brings some absorption. The coefficient is around 0.3. Again, the mix of the different materials bring this very exceptional comfort. What else? Here we have
the fountain.
Oh yes, the fountain is something else. We use it to create a sound masking. So this can help to reduce the speech intelligibility at long distance. So you can keep, even in an open space like that, you can keep some confidentiality. So it means that if people are sitting here, it will be more difficult for them to understand what we are saying, because we want to keep confidential. So it's part of the acoustic design. So we are in the conference room. This was interesting because we had all the challenges to address. For first, the confidentiality. So when the door is closed, it's completely soundproofed, so you can have very confidential discussion. There is no noise going out. It's the elements we use, the partition wall, but also the ceiling, because very often when you do a meeting room, you think about the partition wall, but noise can go through the slab, noise can go through the air ducts, go through the ceiling, so there are a lot of points to address. Then also in this room we have a very comfortable acoustic atmosphere, so it's very clear for the video audio conference, but also for the speech intelligibility. So we use a mix of different materials. You can see the ceiling is made of perforated wood panels that brings absorption in the lower frequency. We have the carpet that brings absorption in high frequencies, and the wall panels, they bring absorption in medium and high frequencies. So we adjusted all the materials and the quantity to reach the perfect balance. So it's really a very comfortable room. People can spend hours, they don't feel tired. It's really a good experience.
My colleague told me that if you talk in here, and no matter where you stand, you almost can hear the same level.
Yes, true. It's part of the design.
How to make that? It's amazing.
We work on what we call the sound decay with distance. So in a room like that, we have a target to have a very low sound decay. So of course, if you are 1 meter from me, the level will be a bit higher, but then with the distance, it will stay almost the same. So this is it's physics, it's sound propagation.
Thank you for bringing good environment to us.
Yeah. You're welcome. It's our job and our mission. You lose around 18% of productivity in a workspace without proper acoustic treatment. So it's a huge number, and it's one of many proofs showing that we need to address this issue when we design a workspace.